All right, listed right here are some steps for being able to solve algebraically linear quadratic systems. You may want to pause the video and write these steps down. I'm not going to read through them. I'll refer back to them as I work through a problem. All right, so here's our first system. We have this first equation. Because you have an x squared, this will be your quadratic, which means this would be a parabola when you graph it. Because this one is x to the first power, this is your linear equation, and when you graph that. So we're going to be looking for the intersection of these two things, but instead of doing it graphically, we are going to be doing this algebraically. All right, so let's refer back to our first step. The first step here says to solve the linear equation for y. All right, so the linear equation is this one right here. It is already solved for y, so that first step has been taken care of for us. If the equation was not solved for y yet, we would need to do that for our first step. All right, so now step 2 says to substitute for y in the quadratic equation. All right, so we're going to take this and substitute it in for the y in the quadratic equation. All right, so what that's going to give us then is negative 2x, and then you have the minus 4 equals negative x plus 2 squared. All right, so let's refer to step 3. Step 3 says to solve for x now. Now, there are several things that are going to be involved in solving for x. The first thing it says is to distribute if necessary. All right, so let's look. We do have a parenthesis that is squared, so we need to distribute this. Now, x plus 2 squared means x plus 2 times x plus 2. Well, you would have to distribute, so that means FOIL this out. X times x is x squared. X times 2 is 2x. 2 times x is also 2x. And then 2 times 2 is 4. Now, when you combine these together, you end up with x squared plus 4x plus 4. All right, so we're going to come back over here and rewrite this now. And remember, there's a negative in front of this parentheses, so we're going to keep that negative. And when we FOILed this out, we ended up with x squared plus 4x plus 4. Now we need to distribute this negative. So doing so will give us negative x squared minus 4x minus 4. All right, so let's take a look back at this. So distribute if necessary, so we did that. Set the equation equal to 0. All right, so when we set the equation equal to 0, I really want the x squared term to be a positive term. So since this is a negative x squared, I'm going to take everything on this side over to the left side of my equation. That will make my x squared a positive term because I need to add the x squared over to this side. So adding x squared will give us x squared. Then we're going to add the 4x to this, which will give us plus 2x. And then we're going to add the 4 over to this side, which will give us 0, so the constant term will cancel out. And that leaves us with nothing on the right side of the equation. So what we have done is set the equation equal to 0 now. So the next thing we need to do is factor that quadratic part out. So x squared plus 2x. Always your first step to factoring is to take out a common factor if possible, a GCF. We do have a GCF of x. We take that out of both terms, which leaves us with x plus 2 equals 0. All right, so we set equal to 0, we factored, and now it says to solve for each factor. All right, so solving for each factor means there is multiplication in between here. We have this factor multiplied by this factor, and we have to get 0 as an answer. Well, if we have to multiply two things together and get 0 as an answer, that means one of these two factors has to be 0. So either this has to be 0 or this has to be 0. So that means either x is 0 or x plus 2 equals 0. Well, x equals 0, that is a solution. It's already x equals. This part we would solve by subtracting 2 to the other side. Alright, so what we have done is we have solved the equation for x, giving us x is equal to 0 and x is equal to negative 2. So if we go back to our steps here, the last step says to find the y-coordinates for the solution points by substituting the x values from step 3 into the linear equation. All right, so these are the x values from step 3. We need to substitute those back into this linear equation right here. All right, so when we do that, that's going to give us y equals negative 2 times the first x value, which is 0. That will give us y equals 0. And then substituting negative 2 in for x will give us negative 2 times negative 2, which is y equals 4. So the two solution points are 0, 0, and negative 2, 4. Graphically, this is where your parabola and your line will intersect each other. All right, let's move on to the next equation. We're going to work through this one a little bit faster now. All right, so what was our first step? First step is to solve the linear equation for y. All right, that has not been done for us this time, so we need to do that. The linear equation is this one. So solving for y, we will need to subtract the 3 to the other side. That gives us y equals x minus 3. The next step is to take this and substitute it into the quadratic equation for the y value. All right, so that's going to give us then x minus 3 plus 2 equals x minus 3 squared. All right, so now we need to solve for x. So we need to combine some like terms, distribute where necessary, and let's go ahead and do that first. So negative 3 plus 2 is minus 1. Distributing here, remember x minus 3 squared means x minus 3 times x minus 3. If you FOIL that out, you get x squared minus 6x plus 9. Our next step is to set the equation equal to 0. Our x squared term, we want it to be positive, and it is positive just by keeping it on this side. So we're going to bring everything from the left side over to the right side. So that'll give us 0 equals, you're going to subtract the x over to here. So negative 6x minus x will give us minus 7x. And then we're going to add this 1 over to this side, giving us a plus 10. So we set the equation equal to 0. Your next step is to factor this. The factoring goes down to x minus 2 times x minus 5, which means we have two things being multiplied together. We have x minus 2 times x minus 5. What that means is that in order to get 0 as an answer, either the x minus 2 has to equal 0 or the x minus 5 has to equal 0. And if you solve each of these, this would give you x equals 2, and this will give you x equals 5. Alright, so we have coordinates where the x value is 2 and the x value is 5. To find the y values, we substitute these x values into the linear equation. So we're going to take this 2 and substitute it into the x value here. So that'll give us y plus 3 equals 2, which means y is equal to negative 1. Then we do the same thing over here. We substitute the 5 in for the x, which gives us y plus 3 equals 5, so y is equal to 2. And again, these are the 2 points of intersection between the parabola and the line. Alright, so let's look at the next one. Step 1 was to take the linear equation and solve for y. That has already been done. Step 2 is to take this and substitute it into y in the quadratic equation. So that will give you x plus 3 equals x squared plus 3x minus 5. There's no distributing on this one now. So the next step is to set this equal to 0. So we're going to subtract x over to the right side, which will give you plus 2x. We're going to subtract 3 over to the right side, which will give you minus 8. Now we need to factor this. The factoring goes down to x plus 4 times x minus 2, which means either x plus 4 equals 0 or x minus 2 equals 0, giving us negative 4 and positive 2. So we know negative 4 is an x value, and we know positive 2 is an x value for our coordinates. So now substituting the negative 4 into the linear equation here, that will give you y equals negative 4 plus 3, which is negative 1. And then substituting the 2 in for the x value will give you 2 plus 3, which is 5. So these are the points of intersection here. Alright, so then last example here. The linear equation is this one because it's x to the first power, so we need to solve for y. So that'll give us y equals 2x plus 10. And then we're going to take this and substitute it into the y value in the quadratic equation. Now we need to make sure we put parentheses around this because we have a negative 2 that has to get multiplied by this 2x plus 10. Then we have this plus 12 and the x plus 2 squared. So step 2, or step 3 rather, we need to solve for x, but we need to distribute everywhere first. So here we need to distribute the negative 2 to both terms, which will give you negative 4x minus 20 plus 12. Over here we need to distribute. Again, this means x plus 2 times x plus 2, which is x squared plus 4x plus 4. We want the x squared term to be positive, which it is on this side. So we're going to bring everything over to the right side of our equation so that we can set this equal to 0. So that's going to give us x squared. We're going to add the 4x over to the right side, which will give you plus 8x. Now negative 20 and a plus 12 combine to give us a negative 8. So we're then going to add 8 over to this side, which will give you plus 12. All right, next step is to factor this, which will go down to x plus 6 times x plus 2, meaning either x plus 6 equals 0 or x plus 2 equals 0, so x equals negative 6 and x equals negative 2. All right, so those are the x values for the points of intersection. To find the y values, we're going to substitute these into the linear equation here. So that'll give us y minus 2 times negative 6 equals 10. Negative 2 times negative 6 is positive 12. And then subtracting 12 gives you a negative 2. All right, so then we take the negative 2 and substitute it in for x, which will give you y minus 2 times negative 2 equals 10, which is y plus 4, and subtracting 4 is 6. So these are the coordinates for the points of intersection between the quadratic, which is your parabola, and the linear equation, which is right here.